All right, so some bonus information here online about advanced matrix wrangling. And there are a lot of crows outside, which never sounds good. So two simple multiplications, right? So there's going to be a matrix times a column vector. Works. We've got m rows, n columns, n rows here. So m by n by 1. So the dot products work, right? This is the basic way of multiplying, is you take rows, dot products with columns. So what we're trying to do is think of more, or see more general ways, or better, more powerful ways of interpreting that multiplication. So we can always do the basic thing, dot product 1, dot product, we can just go through the whole thing. But it's going to be much more powerful to combine some of those operations. And over here, so with two sides, on this side, we're going to have what, we'll use this word all through the course, but we're just starting here. So y transpose. So by default, vectors are always columns. So this is an m by 1 column vector. Y transpose, we'll see this more generally, but let's say it's just a flipping, right? We're just going to flip it. And we're going to make a column into a row, or a row into a column with that little symbol t. So this is a row, y1 to ym, and that works if we take a product with our typical m by n shape of A. And then I've done, so on both sides, I've tried to show how to interpret this. So you can see this, and this is our column picture, where we can see this is taking the columns of A, taking a dot product, taking the weights of X, and then combining, you can think of it as a dot product, but at the column level, right? So we take the columns of A, weight them with the values of X, and combine them, add them together. Right, so here they are, columns, writing them out abstractly. I'm going to put this asterisk in here. So that means run over all the indices there. So that's indicating the first column, right? So ij, j is always a column, I is always, the first entry is always the row, second is column. So the column is fixed. Take all of the entries here. So column, column, nth column is here. So these are the column vectors sitting inside it. x1 is going to multiply this guy, x2 is going to multiply this guy, and xn is going to multiply this guy. We could do all the dot products as I said, but it's better to see it, often better to see it like this. x1 times the first column, x2 times the second column, and so on. So here's an example. So here's A. In this case, it's got 3 columns, 2 rows, and then we have this column vector out here, and this is the combining vector. This has the weights. So the weights are going to be -1, 2, and 0, and we want these columns. So there's going to be a 3, 1 here, 0, -2, and a 2, 2. So we go through and add these up. And so the way to think about this is these are the individual sounds, right? The different instruments, and we're going to combine them. So we need a -3 here, plus 2 times 0, plus, right? So it's just a -3. And this is -1, -4, so it's -5 plus 0. Right. Now, we could do the standard approach, which is just take dot products, right? So there's the first row, dot product with this column. So there's a -3, 0, 0, so we get the same thing, -3. And we could have -1, -4, 0, so -5. So yes, you can go directly to this, but this intermediate step is gives us all sorts of understanding and power. And we're all about power, right? Power and control. No, we're nice people. Okay, so let's see. So y transpose A, this thing. So it's kind of a flip, right? So instead of a column here, when we operate from this side, we need to have a row if we're going to deal with a vector. So this is doing a similar thing, but now we're taking the rows of A and we say, well, we want y1 of that one, y2 of that one, and ym of that one, and we're going to add them all up. And so that's this picture here. So we're combining the rows of A, stacking them all up with these weights. So here's an example, 3, 0, 2, and then this guy. So let's do it. So we're going to have the weights, 3, 0, and 2, -1 and 0. That's the first row, 2, 1. Next row, 0, 2. We can add these up. We want 0 of this guy, so that's just blanked out. We want there's a -3 here and a 0 here, so we get a -3. 3 and 0, so that's gone. This is gone, 4. And as before, we could of course just use the standard approach, which is just to take dot products. So there's a -3, a 0, right? So that's -3. we could take 3, 0, and 4. So these are the same, just as these are the same, but the more powerful understanding is these pictures here. We will come back to this again and again and again. All right, yes.